Alrighty folks, in this video we're going to go over the concept of differentials. So this video we're not going to learn any new derivatives, but we're going to actually go over a really cool and useful application of derivatives. So it turns out that we can use derivatives to approximate the change in a dependent variable. If you are given a function f of x, then the approximate change in y can be found using the following formula. Dy is equal to f prime of x times dx. Okay, so dx and dy, this is what we call differentials. So dx is defined as x2 minus x1. So for these problems, you're going to be saying, okay, let's say I want to change the number of products that I'm producing from 10 units to 15 units. As a business owner, you may want to know, okay, what's the approximate change in my profits that I'll experience if I go from producing 10 units to 15 units? Okay? In that example, x represents the number of units, so your dx will be 15 units, where you're trying to go to, minus the 10 units where you're at now. Okay? So, but a very important part here as we get through these examples, when you're evaluating dy, make sure you plug in x1 in for the x value. So if you're given two different x values, make sure you're plugging in the starting x value, if that's the case. Alright, but the other key point is that dy, the approximate change in the y variable, is simply our derivative f prime of x times dx. Alright, let's get into a couple of examples here. Okay, for example, suppose we're given that f of x is x cubed plus 3x. They want us to find dy and evaluate it when x is equal to 2 and dx is equal to 0.2. Alright, so to recap, dy is f prime of x times dx, our differential in x, which is the change in x is what that means. So since f of x is equal to x cubed plus 3x, that means that f prime of x will be, parentheses, 3x squared plus 3, and that entire quantity gets multiplied by dx. We call this the differential equation, is what this is. It relates how my y values are changing. It relates to how my x values are changing. Okay, so as far as evaluating this, it's pretty straightforward. So dy is equal to, well, what do I plug in for x? I plug in my starting x value, which is 2. So it's 3 times 2 squared plus 3. That entire quantity gets multiplied by dx, which they told us dx is a 0.2. Okay, so this would be a 3 times 4. That's what 2 squared is, plus 3 times 0.2. Excuse me. 3 times 4 is 12. 12 plus 3 is 15. 15 times 0.2 is 3. Actually works out to be 3, okay? So if you take 15 times 0.2, you're going to get 3. So that's what a differential is. So the approximate change in our y value, in our f of x value, as our x is changed by 0.2, our approximate change that our y is going to change by a positive 3. All right, next example. Find dv, the estimated change in volume, if the size of a cube changed from 9 to 8.8. Round your answer to the nearest tenth if necessary. Recall that the volume of a cube is s cubed, where s is the side length of the cube. All right, so I'm going to use different variables here. So v, we're going to let that represent volume. And they tell us that volume is s cubed. So here our dependent variable, or the variable that's acting like x, is the s variable, which is fine. So what's dv? Well, it's going to be the derivative of our volume function. So the derivative of s cubed is 3s squared times ds. So the ds part of the dx part, how do you know which variable? It's just your independent variable. So since we took the derivative with respect to s, that's why it's a ds over there. Okay? So we want to approximate the change as we go from 9 to 8.8. What that means is that we have a starting value of 9, and we end up with the x2 value of 8.8. So what that means is that ds or dx, whatever you want to call it, it's always the second value minus the first value. Okay? In our case, it's going to be 8.8 minus 9, which gives us a negative 0.2. So think of it like this, is what we're doing is the negative indicates our x values or independent values are going down over time, which is true. We went from 9 to 8.8. If instead we went from 8.8 to 9, now you're looking at a positive ds value. All right? And so dv equals, well, what do we plug in for s? Remember what I told you earlier. You always plug in the starting x value. Our starting x value, or technically s value, is 9. So we're plugging in 9. So it's 3 times 9 squared, right? And then whatever that is, it gets multiplied by a negative 0.2. All right, let's see what that is. So 9 squared is 81. I'm going to go to my calculator. I'm going to take 81 times 3. Gives us 243. So it's 243 times a negative 0.2. Remember, we're multiplying here. And let's see what that is. Times a negative 0.2. That gives us a negative 48.6. So what does that mean? That means that as the size of the cube shrink from, let's say, 9 inches down to 8.8 inches, we're saying that the overall volume of that cube is going to decrease by approximately 48.6 cubic inches. That's what that means. The negative indicates you're going to decrease the volume over time. All right? Okay, so that was just a quick little video on how we use differentials to approximate the change in a dependent variable. I hope to see you guys in the next video.